So good morning everyone. So welcome to my YouTube channel Math Spectrum. Today we are going to see lecture 1 on limits of two variable functions of two variable or more. Okay. So limits of functions of two independent variables. Okay. So suppose we have this function y is equal to fx of single variable and we have to calculate limit. We are to talk about limit extending to a of x. Okay, so this is function fx. Okay, and some point a is here. So we check left hand limit, right hand limit. Okay, so limit extending to a from left exists and limit extending to a from right fx exists. Then we say that limit extending to a fx exists and the common value both the limit exist. Okay, both the limit exist and limit extending to a fx, it means left hand limit is equal to right hand limit. Okay, so both the limit exist exist and left hand limit. This is called left hand limit. This is called right hand limit. So if left hand limit and right hand limit exist and they are equal, then we say that limit extending to a fx exists and the common value L is equal to limit is called limit of fx as extending to a. Or you can say limit of fx as a. And we write it mathematically and we write, or we can say that we denote it by v We denote it by limit x tending to fx is equal to L. Okay. Now, now observation. Note that if any of limit, any of left hand limit or limit does not exist or both left and right limits exist, but they are not equal, then limit of fx at a does not exist, does not exist because we in real line we have function of single variable y is equal to fx, and if we checking limit at certain point, so we know that we know that there are only two direction, left direction, right direction. So checking uh, left hand and right hand limit, we have only two directions, okay, and we can check them manually, okay, manually. But once we have a function of two independent variable or more independent variable, the situation is something different, okay. Just you observe the thing, observe the thing, because we have function of let z is equal to fx. Here f is function of two independent variables x and y. Okay, x and y. Suppose we want to check find this limit x y tending to x naught y naught fx. We want to find this one. So situation you see that we have this one x y x x dash y dash. Somewhere point is here x naught y naught. Because in function of single variable, you take any point, let's say A. So we have only left direction, right direction. If left limit or right or limit from left direction, that is left hand limit does not exist, or limit from right direction, that is called right hand limit, does not exist, we simply say that limit does not exist. But here so many directions are there approaching to this point. So if we want to check whether some limit exists at some point, limit of a function exists at some point x naught y naught, we have to check so many directions. There are infinitely many directions. We have to check it one by one. Okay. So there is a formal definition called epsilon delta definition. We have to, if certain function had satisfied that definition at some point, then limit exists. Okay. But showing that function of two variable or more variable limit does not exist, you check two paths where limit exists does not exist at along any path, or limit exists along two different paths, but limit not equal. Then we say that function do not has limit at that point. Okay. So my mean is that okay. So if we found if we can find two paths, or you can say curves along, let's say gamma 1 and gamma 2. So there are two paths. So there are two paths. Let's say it's gamma 1 and this is gamma 2. So along gamma 1, limit x y tending to x naught, y naught, fx does not exist, or along y2, limit x y tends to x naught, y naught, fxy does not exist. Either these things are happening, this any of these things happening, or both the limits along gamma 1 and gamma 2, limit xy fx exist, but but exist along, so along limit exist, but both limits are different, then we can say that limit xy, limit xy tending to x naught, y naught, fxy does not exist. So you can select any path, gamma 1, gamma 2, limit exists along both the path, but limit is not equal, limits are not equal, then we say function do not have limit at that point. Either you select one path or and limit does not exist. It means it is approaching infinity, or okay, then we can say limit does not exist. If any of these things happen, then we can say that limit does not exist. Okay. Now we are doing some example. It will be more clear. Okay. So example, So tell me about this limit x y tending to 0 0 x plus y x minus y. Does limit this exist? Solution. So fxy is here x plus y x minus y. So at 0 0 0 0 is this point. So we are taking general curve y is equal to mx. So we'll check along this. If we take two different m's, path will be different. Okay. So limit. So put this. So if we take two different m, the limit we are getting differently. Okay. So we this function approaching two different value along two different uh, uh, straight line or curves y is equal to mx, which is dependent. So this is dependent on m. This implies limit xy tending to 0 0 x plus y x minus y does not exist. Now example 2, thus limit limit xy tending to 0 0 y upon x exist. Solution. So again take y is equal to mx because we are calculating limit xy tending to. We are verifying whether limit exists. So we have to select a curve which pass through that point 0 0. So then limit xy tending to 0 0 y upon x, that is limit xy tending to 0 mx upon x. So again this is dependent on m. If we take two different m, we have two different such kind of curves and limit we are getting differently. Okay, so this implies limit y upon x xy tending to 0 0 does not exist. So example 3, does limit xy tending to 0 0 x x square minus y square x square plus y square exist. Solution. Again take curve y is equal to x. If power is same in numerator and denominator, then such kind of limit will not exist because power is here 2. It means degree and numerator degree is 2. Denominator degree is also 2. Okay. Then limit Okay, again, which is dependent on M, dependent on M. So this implies limit xy x square minus y square does not exist. Okay. Example 4, does limit xy tending to 0, 0 xy upon x square plus y square exist. Again, we will take y is equal to mx. So limit xy tending to 0, 0 xy upon x square plus y square limit x tending to 0 xy upon x square plus y square limit. So we have to put here value x and x square plus y square x square. So limit x tending to 0 and x square 1 plus m square. So this is m 1 plus m square. Again, this is dependent on this implies limit xy tending to 0, 0 xy upon x square plus y square does not exist. Okay, now example 5. Example 5, thus limit xy tending to 1 to x minus 1 का square plus y minus 2 का square x minus 1 का square minus y minus 2 का square adjust. Okay, so here we have to, here x naught y naught point is 1 2, so we have to select curve. So we can take y minus 2 and x minus 1. So this curve passes through passing through this curve passing through 1 2 point. So that is why we have to take this one. So limit x y tending to 1 to x minus 1 का square plus y minus 2 का square x minus 1 का square minus 2 का square. So x minus 1 का square m square x minus 1 का square x minus 1 का square minus m square minus 1 का square. So 1 plus m minus dependent n. So this implies doing xy tending to 1 to x minus 1 square plus y minus square x minus 1 square 2 square does not exist. Okay. So today's lecture up to this. If you have any problem, you can comment on my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture. Thank you very much.